All right, so 2.4, real zeros.
We're like in the middle of a chapter right now.
Yep. Of polynomial functions, because we're behind.
Uh-oh. Do you have to remember stuff from 2.1 to 2.3? Oh, that's good.
I mean, you always have to remember the stuff that comes before it, but. All right, so we are going to do a long division refresher.
Oh, no.
I'm sorry.
32 into 3,587.
Repeat number?
Oh my goodness gracious. I hate
Okay, an x over the 3.
An x over the 3?
How are you doing it? That's not how you guys do long division?
No.
Okay, so what?
I just see how many times it can go into the number.
1 over
X
5.
over 3.
Yeah, so 1 is going to go over the 5.
That's what I meant. Like, you just put an x over the 3.
Over. Then you have 38. So then you have another 1.
Wait, what?
Yeah.
Oh,
so
you're
3
yeah.
left over.
So you're subtracting.
You guys think.
So then that goes in 1 time.
2, 67, 2,
Which is 2.
and that's 64. And then you have the remainder of 3.
Okay, so 112 with a remainder of 3. So now we're going to do long division with letters.
Excuse me?
What?
Huh?
That sounds
So
fun.
now there will be an x.
Well, I was saying, like,
hope.
32 didn't go into 3, so I always put an x over it until it goes into, like, the thing.
Yeah,
You were
the
so
multiply sign.
confident.
All right, so 3x plus 2
I'm right.
going into 3x cubed plus 5x squared plus 8x plus 7.
Huh?
3x plus 5x. Oh, is this where you like move the thingies around so then like the thingies can go with the thingies and then the other ones thingies?
What are you even saying?
Yeah,
Berkeley?
Sure.
Do you know what I'm saying though?
All right, so what we're going to do is we're looking at this biggest x value here, okay, and we've got to cancel out this biggest x value. So what do I need to multiply this by
3.
to give me this?
Square root of
No, multiply. X squared. So since it's an x squared, it's going over top of the x squared term.
3. Okay, this is not going well.
So 2x squared and 3x cubed. Okay, I'm subtracting all of this stuff off. So the 3x cubes are going away. 5x squared minus 2x squared is 3x squared. And bring down the 8x and the 7. Okay, you bring down everything. Okay, so then what is this being multiplied to give you this? That's an x. So then x times 2 is 2x. And x times 3x is 3x squared. Subtracting. So that gives you 6x plus 7. 3x goes into 6x 2 times. So plus 2. So that's going to give you 4. And 6x. Subtracting. So that's going to give you 3. And then the way that we write this when we have a remainder with something like this, we write our final answer as x squared plus x plus 2 plus 3 over 3x plus 2.
I remember doing that.
Beautiful.
Because my brain just couldn't comprehend.
Now, do you notice anything about these two problems?
They're probably the same. They both have remainder.
They both have a 3 in it.
They're the
Yeah.
same because
They're
one,
the
one,
same
two.
problem but with letters in it. It's
They're the
really-
exact same problem. I just added letters to the second one.
What is that?
Because it's
Oh,
3,587 and then it's 3,587.
So I could just, if I really am struggling with a problem, I could just take the x's out and then solve it and then add plus signs to it.
Yeah.
Hey, why is it so warm?
Why did you squeeze out without?
I didn't mean to.
I can't remember if it really happens, but there could potentially be a negative. I don't think it really happens that often, but it could potentially, so you might have to watch for that, but yeah.
Having some technical difficulties.
How? You should hold
Okay.
simple stuff.
It's just so gross.
Well, most people don't want it.
I was about to say that.
All right, so checking. The divisor times the quotient plus the remainder is equal to the dividend. So for this problem that we did up here, the divisor is 3x plus 2. The quotient was what was this answer here at the top. So times x squared plus x plus 2. And then add the remainder. The remainder was 3, so plus 3. So we're going to superfoil this. So that gives us 3x cubed plus 3x squared plus 6x plus 2x squared plus 2x plus 4, and then add the 3 at the end. Then this is going to simplify to 3x cubed plus 5x squared plus 8x plus 7. And that should be what we started with underneath up there.
Gary, did you go to 4th grade?
I didn't
No,
know.
my mom homeschooled me for the first half, so that's why I'm so.
I didn't know what it was either, so I just waited for her to fill in the numbers. So if that makes you feel any better.
If it makes you feel better, I never remember which word goes where. I just know what the thing is supposed to be.
Grade, and they were all upset at me because I didn't know cursive and
I can't hear
assumed
you.
I knew division. I remember that.
The quotient's always the answer.
What made me mad is she told me not to worry about it, and then one day she was like, "Why aren't you writing your spelling test in cursive?" And then she gave me a 50 because I didn't write it in cursive, and I was like,
It's okay, you just didn't get a 50 because you didn't know any of the spelling words. You just
No.
didn't write in cursive.
I wouldn't
I
know.
got a 50 because I didn't know the spelling words.
Yeah, Berkeley doesn't know how to
My
spell.
mom made me write my
Okay,
spelling
quick
words 3
question.
times
How do
every
you
single
scroll
night.
on the notes
My
without
mom would
writing?
yell at me.
Because, like, when I go to scroll, it just, like, writes
You have
on
to change the setting to, hold on.
Well, my mom would like yell at me. and
I'm
make
clicking
me
the
do
wrong
spelling
thing.
bee
Hello.
test at home.
Over
I'm so
here,
crying.
and these dots come up. You have to turn off draw with finger.
Yeah.
Oh.
My mom,
Thanks.
my mom made me write my spelling words 3 times every night. It's terrible.
Oh,
All
I
right.
have to do that because I knew all my spelling.
Division algorithm for polynomials.
We're smoking. The benefit of going to church?
What the heck are you talking about?
That's a really
All right, let f of x and d of x be polynomials with the degree of f greater than or equal to the degree of d, and d of x not equal to 0, then there are unique polynomials q of x and r of x called the quotient and remainder such that f of x equals d of x times q of x plus r of x. Where either r of x is equal to 0 or the degree of r is less than the degree of d.
How do you not know?
Yeah, even Berkeley
All right, the remainder theorem.
I'm cracking myself up.
Hope y'all understand all this so far.
I think so. It's making sense.
I'm just saying with all the talking. If a polynomial f of x is divided by x minus k, then the remainder is r is equal to f of k. So if it just asks you to find the remainder, if it is something like x minus k, not like 3x squared plus 7, okay, it has to literally just be like x minus 7, then you can use this theorem to find your remainder. So, for example, find the remainder when f of x is equal to 3x squared plus 7x minus 20 is divided by the following. First, we're going to do x minus 2. So when it's x minus 2, okay, the formula is x minus k. So if this is a minus sign, then k is just this number. Okay, if it was a positive sign, then k would be negative. So our k is equal to 2. Then based on our formula, r is equal to f of 2. So we're going to put in 2 for x up here. So that's going to be 3 times 2 squared plus 7 times 2 minus 20, which is going to be, let's see, 12 plus 14, is that 26 minus 20. So our remainder for this would be 6. Let's look at another one. So if we had instead x plus 4 for the same problem, okay, remember the formula is x minus k, so since this is positive, that means the k value is going to be negative, so k is equal to negative 4. So r is equal to f of negative 4. So 3 times negative 4 squared plus 7 times negative 4 minus 20 is equal to, so let's see, we got 16 times 3, is that 48, plus 7 times negative 4, so minus 28, so that 20 minus 20 is 0. So that means there's no remainder. So from that, this gives us, okay, more information that we're going to need, that x plus 4 is a factor of 3x squared plus 7x minus 20. So x plus 4 is equal to 0, so the x-intercept is at x is equal to 4. Or sorry, negative 4. Come on. Okay, we're obviously going to do a lot more with that, but just so you see it.
Are you doing examples today too?
All right, factor theorem. So a polynomial function f of x has a factor x minus k if and only if f of k is equal to 0. So basically, this right here is what we just saw in this example. Fundamental connections. For polynomial functions. That's the title. There we go. Okay. So for polynomial function f, and real number k, the following are equivalent. First, x is equal to k is a solution or root of the equation f of x is equal to 0. 2, k is a 0 of the function f. 3, k is a x-intercept of the graph of y equals f of x. And 4, x minus k is a factor of f of x. There's a little bit more notes that I was going to do later, but I'm just going to go ahead and do them now so you have them all. Alright, so then we have the rational zeros theorem. So suppose F is a polynomial function of degree n greater than or equal to 1 of the form f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 0 with every coefficient an integer and a sub 0 not equal to 0 if x is equal to p divided by q is a rational 0 of f where p and q have no common integer factors other than positive or negative 1, then p is an integer factor of the constant coefficient a sub 0 and q is an integer factor of the leading coefficient a sub n. Alright, one more semi-long note thing. There won't be 2 examples. Alright, upper and lower bound test. For real zeros. Let f be a polynomial function of degree n greater than or equal to 1 with a positive leading coefficient suppose f of x is divided by x minus k using synthetic division. Okay, and I'm going to do a refresher of synthetic division in a minute as well. Then the first thing, if k is greater than or equal to 0 and every number in the last line is non-negative positive or 0. Okay, then k is an upper bound for the real zeros of f. And if k is less than or equal to 0 and the numbers in the last line are alternately, okay, so meaning alternating, okay, back and forth, non-positive or non-negative and non-positive. Okay, so they could be 0. Then k is a lower bound for all the real zeros of f. Alright, so I'm going to do an example of synthetic division here as part of the notes, and then, yeah, or I might do like 2 examples of synthetic division here in the notes, and then we'll do the other stuff that uses all of these notes that we've taken. Alright, so 7 through 12 say to divide using synthetic division and write a summary statement in fraction form. Okay, the summary statement, just to go back up, will look like this. What's in this green box right here? Okay, that's what your summary statement should look like. A few things about synthetic division to just remember is that it has to be in that form, that x minus k or x plus k. Okay, when we do it, if it's like x squared plus 3 or something like that, we can't do it. It has to just be like a single x term to be able to do it. So, starting with number 8. Let's do this. All right. So we have the problem 2x to the 4th minus 5x cubed plus 7x squared minus 3x plus 1 divided by x minus 3. So since this is just an x, okay, by itself, we can do this. It's minus 3. So since that's the form, okay, in this top box, okay, we're putting a 3. Had this been x plus 3, this would be negative, okay? So this sign is opposite whatever is written here, basically. Okay, and then we copy down all the numbers, okay, with their signs. If something is missing, you have to put a 0, okay? So let's say that that x squared term was missing, you would need to put a 0 in for the x squared or your answer won't be right, okay? That's honestly the biggest mistake. Pretty much everybody's fine with the process, but you forget that one thing and it throws your answer like completely off. So, all right, so we're copying down a 2, negative 5, 7, negative 3, and 1. And a lot of times over top of my first term, I like to write what it is because, well, there's a couple reasons. One thing is in this section, you need to know what it was, but then there's other things that come up later where like you'll keep going sometimes, and so you have to know like what term it's like going to. All right, so then leave one line to fill in your stuff. So the first number always just gets dropped down. Okay, then we multiply what's in the box by what's down here. So 3 times 2 is 6. Okay, and then we add these together or subtract them as the case may be. So that's 1 times 3. So put 3 there. Add them together, that's 10. 10 times 3, 30. Add those together, it's 27. 27 times 3 is 81.
It is 81.
Yeah. No, I was looking at, I'll tell you in a second what I was looking at. Add them together, 82. I was looking at the 82 on my paper and trying to figure out how in the world I got 3 times 27 was 82, and then I realized I was looking at the wrong thing. So this right here is your remainder. Okay. So when I go to write my summary statement, okay, I get this number here. The reason I always write what it starts with, this becomes an x cubed term, okay? This always drops by 1 power. So if it was x to the 4th to start with, it's x cubed. If it was x squared to start with, okay, then it's just an x. It always drops by 1 power. So my answer is 2x cubed plus x squared plus 10x plus 27 plus 82 over x minus 3. Okay, I'm pretty sure we had done synthetic division. Does this look familiar?
Yeah.
Pretty sure we did it last year. So. All right. Number 10, I'm going to have y'all walk me through this one, and then we're just going to do one more, and then we'll be done for today. All right, 3x to the 4th plus x cubed minus 4x squared plus 9x minus 3 all over x plus 5. Okay, one thing to just, I didn't mention it earlier, make sure the terms are in order. Okay, on occasion they may try to like throw you off and give you one term that's like out of order, so just make sure you pay attention to that. Give y'all a second to write this down, then you can tell me what to do. Alright, so what do I need to do?
Start off with the negative 5.
in the little box.
Okay.
You just go in order of like 3, 1, negative 4, 9, and negative 3.
Remind yourself. The
Drop the
first
first
term
term
is
down.
4. I can't speak, so I have to go.
And you drop the first term down. Then you multiply it with the negative 5, so it'll be negative 15. And then it'll be negative 14, and then you times it by 3.
Wow.
Wait, is that
My
5?
calculator
Oh.
did.
Is it?
This?
Yeah.
Yeah, it's 5. Negative 5.
Oh, it is 5. I'm blind. 70? Positive 70, right? So it'll be 66 times 5, so it'll be 330, right?
Jeez.
Negative, but yes.
So you plus 9, so it'll be 321. Negative 321. And then you multiply it by 5, it'll be, ooh, 16. It's like 1,600. Yeah.
That's all we're trying.
Okay, and you'll have your calculator, so if you have something like that, you can do it on
Oh,
there.
I was just doing it in my head.
Well, I mean,
Good for you.
you can. I was just saying you have it if you need it. All right, so then final answer would be written how?
3x cubed minus 14x squared whole cubed, still trying to do
Plus
it.
66x minus 320.
Plus
With
1.
602 over x plus 5.
Yep.
From what? Right?
I know, I haven't like ran like this in weeks.
I like the Apple
Well, really, we
Pencil.
didn't
It
write
makes
this much
life a
during
lot
the
easier. I don't have to
Exactly.
flip
That was
pages
4
or
weeks.
anything.
You
A month.
gotta pick
All right, this next problem I'm just going to set up for you. I'm not going to work it because it's just irritating. You'll see why when I write it down. X to the 8th minus 1 over x plus 2.
Yeah, that's a lot of zeros.
That's a lot of zeros.
Okay, so what goes in the box?
I'm confused.
-2.
So then the biggest term is x to the 8th, so I'm writing that down. So that's going to be 1. Okay. X to the 7th is missing, so I write a 0. X to the 6th is missing, write a 0. X to the 5th is missing, write a 0. X to the 4th is missing, put a 0. X cubed is missing, put a 0. X squared is missing, put a 0. X is missing, put a 0.
the negative.
And then we have a -1.
Can we, yeah, I don't want
Okay, wouldn't be hard, follows the same procedure. Okay, this is where it'd be really important to remember what term you start with. Okay, so you would just start like normal, bring down the 1, it's -2, bring down the -2, that would be 4. Okay, and you just keep going all the way down until you get all the way across, and so on and so forth, and then you get an answer. That's obnoxiously long. Okay, I'm not gonna finish the problem, it's a bunch of zeros. If you want to finish it and write it out, then you can, but I don't really see a point in finishing this one when it's just the process. So that's the end of those notes.